You are welcome to our class today, and in this video we'll be looking at gradient of a line. Gradient of a line is a sloping degree of a line joining 2 points. A sloping degree of a line joining 2 points. It can also be measured by the ratio of the increment of a vertical axis to that of horizontal axis. So let's look for this, and let's use a diagram to explain gradient of a line further. If you have, this is y-axis, this is x-axis. So we have x, we have y here. In our previous video, we have seen how we can locate points, so we don't need to explain any further. If you have plotted a graph or located a point where we're having y1, we're having x1, we're having s2, we're also having y2. By the time we plot this against each other, we are going to have this form of graph. From our last video, we're able to do this. If we call this point, we call it point A, this point we call it point B. Now, from the definition of gradient, gradient is defined as the increment of the vertical axis to that of the ratio of the increment of the vertical axis to that of horizontal axis. If you are to join this point together, join it this way, we locate this one. Now this one gives us a right angle triangle. Let's call this point, maybe we call it point N. Gradient of line can also be called slope, and it is denoted as small letter m. Now the increment of y-axis means change in y, change in y. Then the increment of x-axis means change in s. Then slope or gradient defined as the ratio of change in y over change in s. So therefore we have gradient or slope. The symbol for gradient is small letter m, equals change in y, which is increment in y-axis over increment in x-axis. Then change in y means y2 minus y1 over x2 minus x1. So this is what we have to be gradient. So from the definition, as a sloping degree, if you look at this triangle ABN, a right angle triangle, if you put an angle here as a sloping degree, we can also find our slope in another dimension. If I bring out these two right angle, the right angle triangle, this is B, this is point M, and this is point A. This is the sloping angle. I'm trying to bring out this right angle triangle out. So this is our change in y, this is our change in s. If I put change in y here, then we put our change in s here. We see that we find from trig ratio, if you find the tangent of this angle, we see that tan theta equals opposite over adjacent. Opposite to this angle theta is change in y, which is bm. The adjacent to the angle is am, which is change in s, which will be bm over am, opposite over adjacent. That will be change in y over change in s, which will give us y2 minus y1 over x2 minus x1, which is tan theta. So therefore we can just say that tangent theta equals to gradient. gradient or slope. So we say gradient equals tan theta, which means that if you are given sloping angle, we can use it to find our gradient. With this tan theta, we can see that slope can also be tangent of the angle of inclination to the horizontal from our diagram. The horizontal is change in x and the angle of inclination is theta. So our slope can also be what? Tan theta. Let's look at this for line y equals mx plus c. M is called the slope, which is called the gradient. Then where C is the intercept on y-axis. Intercept on y-axis. Also from this line, also from line ax plus by plus c equals 0. Let's make y subject of the formula. If you make y subject of the formula, we have by equals minus as minus c. If you divide both sides by b, dividing both sides by b, this will remove b. So y equals minus a over b s minus c over b. If you now compare this equation to the general equation of a straight line, we will see that the gradient or slope equals minus a over b, and the intercept equals minus c over b. So we apply this when we are given an equation in the form of ax plus by plus c equals to 0, and we want to find the gradient and intercept. What we need to do is to make y subject of the formula and compare it to the general equation of a straight line, y equals mx plus c. From there, we can get our slope and intercept. So this is what we call gradient of line under coordinate geometry. In our next class, we'll be looking at distance between 2 points. You can't afford to miss this next class, which is very important. Make sure you subscribe to this channel. Thanks for watching.